Hello dear students, I welcome you all to the third video on mathematical reasoning. So before I start, I expect you to watch part 1 video and part 2 video so that it's easy for you to understand this particular lecture. Okay, so without wasting much time, let us begin. So today we are going to make use of the truth table which we have learned so far. That is the truth table for conjunction, disjunction, negation and biconditional statement. Okay, so let us start with the second problem for the day. Okay, so if you see here, you have to draw truth table for this particular compound statement. Okay, now whenever you draw truth table, you always need to look for the statements given to you. For example, here P and Q are the only two statements given to you. Okay, so you need to in the first two columns you have to write P and Q. Okay, and according to Bodmer's rule, we need to solve whatever is given inside the bracket, right? So first we will try to construct the truth table for this particular quantity. Right, now here you see that there is OR, right? So basically you need to know the truth table for OR as well. Okay, and here instead of P you have negation P. Okay, so you are taking negation P or Q. All right, so let me first draw P and Q. Okay, so first and foremost you have to remember this. Okay, so first put TT, then TF, then FT, then FF. All right, okay, now as I said, we need to solve whatever is there inside the bracket, right? So we have negation P first. So let me draw table for negation P. Now you clearly see that when P is T, then negation P becomes F. Alright, so if you are not able to understand, let me show you here. So I have drawn negation P out here. So if P is T, then negation P is F. If P is T, then again it becomes F. Here it is F, so that's why it has to be T. Here it is F, that's why it has to be T here. Alright, okay, so now we need to take OR of negation P and Q. Alright, so you need to know the table for OR, right? So I have given you table for OR for your reference. All right, so it is F or T, right? Negation P or Q. So F or T gives you, so F, okay, so F or T gives you T, right? Okay, so this quantity, let us see what is the truth table for this. Okay, so I have written negation P or Q. So as you know, F and T gives you T, right? You can see F and T gives you T. Now next you have F and F. So F and F gives you F. So that's why you have F out here. All right. Okay. Now you have T and T, right? So you have T and T gives you T, right? And T and F gives you T. So basically, in other words, whenever you have got two F's, then only you'll get F. Otherwise, you'll get T in case of OR. All right. Okay. Fine. So we have found whatever is there inside the bracket. Now we have to take the negation of this whole quantity, right? Okay, so wherever we have got T, we have to write F, and wherever we have got F, we have to write T over there. Okay, so as you can see from here, T became F, F became T, T became F, and T also became F. All right, so this, okay, so this full quantity gives you truth table for this particular compound statement. All right, so you may pause the video to note down. Okay, now let me take one more sum from this particular number. Let me take question number 4. Okay, so this is going to be a little longer truth table. As you can see, there are many operations being performed. All right, so here you can see that only statements are P and Q. So as usual, you have to draw. Okay, and let me use AND is there and OR is there. So I have drawn truth table for your reference out here. Okay, so as I said, only P and Q are there. So we'll draw P and Q. Okay, so we need negation of P, right? And we need negation of Q as well. So let us draw negation P and negation Q. Okay, so let's have a look at only negation P. So if P is T, then it became F. If P is T, again this became F. If this is F, this became T. This F, this became T. Similarly, negation Q. So Q is T, that's why negation Q has to be F. This is F, this has to be T. This is T, this has to be F. This is F, this has to be T. All right. Okay, so let us see whatever is there inside the bracket. Okay, so first thing we need to see is negation P or Q, right? So negation P is here and Q is here. So you have to take OR of these two. Okay, so wherever FF is there, only there we'll have F, otherwise we'll have TTT. All right. Okay, very good. Now we have this as well, isn't it? So let us see what is the truth table for this. Okay, so we have to take OR of negation P and negation Q. So we have got negation P and negation Q out here. So here FF is there, so that's why this is F. Here FT, so that's why T. This is TF, so that's why TT gives me T. All right. Okay, so at last we founded this and we founded this. Now we have to take AND of these two. Okay, so this is there, this is there, so I have to take AND. Now let us go to AND table. So in AND we see everything is false. If P and Q both are true, then only my answer will be true. Okay, so here these two are only true, so that's why this is true. Okay, I'm sorry, we have to see these two, right? So here I see T true true, here also true true, so that's why here I'll get true, here I'll get true, here it will be false, here it will be false. All right, so this will be your truth table for this particular compound statement. So you may pause the video to note down. So the next topic that we are going to learn is called tautology and contradiction. So let us try to understand what are the meaning of tautology and contradiction using definition. So the definition for tautology says a compound statement is said to be tautology if it is true for all possible values of its component statement. Now we know that a compound statement is made up of simple statements, so they are also called component statements. Okay, so no matter what are the truth value of your component statement, a compound statement, if it is always true, then such kind of compound statement is known as tautology. All right, and contradiction is just going to be opposite of tautology. Okay, so basically in contradiction your truth value is always going to be false. All right, okay, now having understood tautology and contradiction, let us get familiarized with one of the very important topic called logical equivalence. Okay, so logical equivalence means here we are going to deal with two different compound statements. Okay, and if their truth value, okay, if their truth value appears to be same, then such kind of equivalence or such kind of compound statements are called equivalent compound statements. All right, and such kind, okay, so for example S1 and S2, if they are two compound statements, then they, and assuming that they are logically equivalent, then we use this symbol in order to say that S1 and S2 are equivalent to each other. All right, so this is all about the definition. Now let us take up some problems in order to understand these many things. So you may pause to note down the definitions. Okay, so question number 3 says, for any statements P and Q, show that. Okay, so this and this, this is tautology and this is contradiction. I'll just take up one problem, you'll do the other one by yourself. Okay, so we have, okay, as usual, we need to draw truth table because we want to see the truth value. Okay, so if all the values of this turns out to be t, then it has to be a tautology, because a tautology is nothing but a compound statement whose truth value is always true. All right, okay, so we have got only two statements P and Q, right? And you already learned how to draw truth table for such kind of compound statements. So P and Q is there inside bracket, right? Here also we have got P and Q, right? So basically we'll first find what is P and Q. Okay, so we know that P and Q is this one, right? So and will be true if both the component statements are true, otherwise it will be false. Okay, so this is found. Now we have to find negation of P and Q. So let us find what is the negation of this. Okay, so negation will be just opposite. So this is T, this is F, this is F, this is T, so everything becomes T, T, T. Okay, so we have got this, we have got this, right? We have to take OR of this and this. All right. So or will be false if both the statements are false. So here this is true, this is false, this is false, this is true, this is false, true, false, true, right? We don't have FF. So that's why all my answer turns out to be TTT. All right. So we see that all the truth values are T, right? So that's why this statement has to be a tautology. All right. So you may pause the video to note down. You will try question number 2 by yourself. Okay, so let us see this one. So basically here what is given, we need to show that this and this, okay, so they are logically equivalent. Okay, so there are how many statements? Let us see, there are 3 statements this time. Okay, so you have to be very careful while writing the truth table for 3 different statements. Okay, so we have PQR, so these are the possible values. Okay, so there are going to be 12 I'm sorry, there are going to be 8 combinations. Okay, 8 rows has to be there. 1 2 3 4 5 6 7 8. Now this will come to you only by practice. Okay, so if you don't practice, then you will fail to write down at least this much also. Okay, so you have to practice, then only you will be able to write this much. So do we have negation here? No, we don't have negation. Instead we see that there is Q and R. So let us make use of these two and write what is Q and R. Okay, so Q and R is written. So since this is AND, so if both are true, then only it will be true. So here it is TT, so that's why T. Alright, so here also we have got TT, so that's why T, otherwise everything became false. Okay, so now we founded this. Now let us find this statement. Alright, so let us find P or this. Okay, so let us make use of this and this column. Okay, so we have to take OR of this column and this column, right? So OR becomes false if both statements becomes your false. All right, so do we have such case here? So let us see, this is TT, so that's why it will be T. TF true, TF true, TF true, FT true, FF, so this becomes your false. And there is FF, this also becomes false, this also FF, so this also becomes false. Okay, so the last 3 rows becomes your false, everything is true. So this is your truth table only for this one. Now let us find what is the truth table for this. Here we see that there is P or Q. So let me make use of these two and find the OR of these two. Alright, so we have P or Q, right? So here we see that F and F, we have FF here only. That means here we said, see that this is F, this is also F, this is F, this is also F. So that's why this is turning out to be F out here, everything is true. Okay, so next we need to find P or R. So let's make use of P and R. Okay, so we have here it is false because this is also false, this is also false. Here also it is false. Why? Because this is also false, this is also false. Okay, now we need to take AND of this and this. That means we need to make use of these two and write the AND of this. So T and T gives me T, T and T gives me T, T and T gives me T, T and T also gives me T, T and T gives me T. Otherwise everything becomes false, right? So that's why this is my truth table for right hand side. Okay, now if you see here carefully, we need to show that this and this, they are equivalent. That means this and this, they are equivalent. Now if you see here, this is T, this is also T, both are same. This is T, this is also T, this is also T, this is T, this is T, this is T. So basically if you see truth table for this compound statement and this compound statement, both are exactly matching, so they are identical to each other. So that's why I say that these two are equivalent to each other. Alright, so you may pause the video to note down. Okay, so let's see the last question for the day. So question says, if any 3 statements P, Q and R show that the implication P and Q implies R and its contrapositive, that is this, are logically equivalent statement. So basically you are using conditional statement here. So let me write down your conditional statements truth table for the reference. Okay, and since we have got 3 statements here, so we need to draw these many columns as well, right? Okay, so we need P and Q. Okay, so let us make it so P and Q, that is the first 2 columns, and write down the AND statement for these 2. Okay, so the AND statement becomes this much, right? So T and T gives me T, T and T gives me T, T and F gives me false, and similarly everything becomes false. Okay, fine. Now we have P implies Q, right? That is, this statement has to be written, right? And from this we see that only TF gives me F, otherwise everything becomes true, right? Okay, so we are checking this way. Okay, this implies this, that's what we are checking here. Okay, so as we said, T and F becomes F, so we have TF only here, right? T implies F. Okay, so this becomes F and everything becomes true. Okay, so this is your truth table for only this statement. Now in this particular statement we have got negation of all the statements, that is P, Q and R. So draw the negation. Okay, so negation becomes this much: P, Q, R, everything is true, so everything becomes false, and similarly other things also happens. Okay, so let us check what is our this statement according to Bodmer's rule. Let us see what happens to the bracket. Okay, so within bracket we have got OR of negation P and negation Q. So let us take OR of these 2 columns. Okay, so if you take OR, then you will get this much, right? Okay, so if both the statement is false, then only you will have false, otherwise everything becomes true. Okay, now we need to show negation R implies this, right? So this implies this, that's what we need to see. And we know that T and F, right? T implies F gives me false, otherwise everything becomes true. So T implies F becomes false and everything becomes true in this case, right? Okay, so observe this column and this column. So they looks same, right? So that's why this statement and this statement, they are logically equivalent statement. All right, so you may pause the video to note down, and here is a homework for you. Okay, so you need to do this homework and you will prove De Morgan's law, which we have learned in the last video. All right, thank you very much. Again, give a like if you have understood my teaching. Thank you very much.